Hi, my name is Michael Hatfield, and I've chosen to do my capstone project for the Applied Data Science program through MIT and Great Learning on the used car price prediction model using machine learning. So why is this an important problem to solve, and what is the intended goal? The used car market in India is growing rapidly, but it is faced with substantial uncertainties in both pricing and supply. This unpredictability makes it challenging for most used car dealers to determine the value of a car, as various factors such as mileage, brand, model, and year can affect its worth. Solving this problem is crucial as it guarantees that used car dealers receive fair and accurate compensation while also supporting the continued growth of the used car market. The objective is to create a pricing model that can precisely estimate the cost of used cars based on specific attributes. This pricing model will assist used car dealers in creating profitable business plans. So what are the key takeaways and next steps? In this project, I employed a random forest regression model and basic data pre-processing to accurately predict the price of used cars. I compared the performance of the random forest regression model with linear regression and decision tree regression models. To optimize the hyperparameters of the random forest model, I utilized grid search cross-validation. The model was built using a data set of 7,253 used car listings, which was split into training and testing data using the 70-30 ratio. The initial results of the random forest regression model showed a training accuracy of 0.978 and a testing accuracy of 0.852. The most influential features were power, year, engine size, kilometers driven, and fuel mileage. By optimizing the random forest regression model, I was able to achieve a training accuracy of 0.97 and a testing accuracy of 0.861. Although the results of random forest model were promising, there are still some margin for error. The next step will be to address all the remaining risks and challenges. What is it that we're trying to solve using data science? We're trying to create a regression pricing model for used cars, and we must use data science and a data set that includes the following fields: serial number, brand and model name, selling location, model year, total kilometers driven, fuel mileage, transmission type, previous ownership, engine size, horsepower, number of seats, and the price of a new car in the same make and model. In developing this model, it is crucial to identify and incorporate the most critical features in the used car data set. So what are the key points that describe the final proposed model? Before starting the process of developing any regression model, the data needs to be cleaned and organized into a usable data set. Missing or null values, for example, in the fields for number of seats, mileage, horsepower, and new price, needed to be dealt with, as well as deciding which features of the data set to use. For example, because there are a large number of unique car names in the data set, I refactored this field to brand, and this allowed me to get a better feel for the number of each brand of car in the data set. If we assume the data set is a true representation of the population of used cars in India, then this feature can become useful. So what are the key points that describe the final proposed model? I created and tested regression models in a linear regression model, random forest regression model, and a decision tree regression model. After developing, testing, and refining each of those models, I compared the final results of each to determine which would be the best fit. According to the results, I determined that the tuned random forest model performed the best and is the most appropriate based on the data set I was given. Assuming this data set is an accurate representation of the population data, we can therefore conclude that this model would be deployed in a real-world case. So what are the key actionables, benefits, and/or costs? The purpose of our used car price prediction model is to assist used car dealers in obtaining fair compensation for their vehicles. Currently, our model is capable of estimating the value of a used car within a reasonable margin of error, but reducing this error rate to zero is a priority. To maximize profit for used car dealers, it is recommended to focus on acquiring more one-owner cars, cars with automatic transmissions, high engine power cars, and selling in the southern city markets. Furthermore, to finally realize the potential of this model, more data on the used car market in India should be gathered and analyzed. So what is a valid solution that is likely to solve the problem? The random forest regression model was chosen as the optimal solution due to its ability to handle continuous variables and perform regression analysis. Unlike linear regression, the random forest model can accommodate nonlinear solutions, making it more suited to real-world situations. Additionally, this model requires minimum data processing. While it is not perfect, it can be improved through further data collection and an optimization of the forest parameters. In summary, the proposed solution process was, number one, gather the data for used cars. Number two, the data set is cleaned and pre-processed. Number three, missing value treatment and feature engineering. So if there's missing data or if we wanted to refactor some of the field names and concatenate those. Random tree regression model and tuning, and then that results in an accurate price analysis and price predictions of used cars. So what are the key risks and challenges? A major challenge in this process is the possibility of misinterpreting the data and making incorrect predictions about the value of a used car. This failure in our model could result in significant financial losses for both individual dealers and businesses and harm the rapidly growing used car market in India. To mitigate this risk, it is necessary to gather more data on used cars and their value to improve the accuracy of our pricing predictions. A process to validate the credibility of our model, such as a certain used car value assessment, should also be established. A significant challenge in this regard would be collecting, processing, and cleaning of a larger, more diverse data set to make the random forest regression model capable of accurately predicting the prices of even the rarest and most unique cars. This would involve obtaining information from all types of car brands and models, as well as expanding the database to include additional features such as exterior color, interior design, and amenities such as GPS and radio. In conclusion, I would like to thank the professors at MIT for taking the time to answer questions during the live classes as they arose. I would like to thank the staff of Great Learning for putting this program together and working with each of us to help facilitate learning during the past 12 weeks. I would like to thank the mentors for taking their time to work with us in small groups or one-on-one to help clarify the more difficult concepts. And finally, I would like to thank my program liaison, Prashi, for helping our cohort navigate the courses and challenges we all faced. Thank you.